Welcome back to the start of a new unit. In this unit, we'll be studying parallel and perpendicular lines in more depth. We'll start with some algebra applications of parallel and perpendicular lines, and then we'll do some proofs. And then toward the end of the unit, we're going to make some connections with what we learned in algebra last year, parallel and perpendicular lines on a coordinate plane. So this video is just going to introduce you to some vocabulary and terminology that you're going to see used throughout this unit. Much of what you see tonight in this video will be familiar to you. So there are three types of lines that we consider in geometry. Parallel lines, we have defined before, are lines that are coplanar and they never intersect. So in the figure that you see here to the right, AB and EF are parallel, as are EG and FH. Now notice in the figure we can't make any other conclusions about parallel lines because nothing else has been marked for us. So when we mark up a figure to indicate that something is parallel, we use these arrows. And then to indicate a second set of parallel lines, we would use a double arrow. If we had a third set of parallel lines that were parallel to each other but not to any of the lines that we've already seen, we would use three arrows. So perpendicular lines we've already defined. We know that they intersect at right angles or 90-degree angles, as indicated by a little square on the diagram where the right angle would be. So in this figure, we can conclude that AB and AE are perpendicular, as well as EG and GH, because again, that's indicated by that little red square in the corner. Now, skew lines are something new. Like parallel lines, skew lines never intersect, but there's an important distinction here, is that skew lines are not coplanar. So skew lines are lines that never intersect, but they don't lie on the same plane. So they're not parallel. In this figure, an example of skew lines would be AB and EG. As you can see, AB and EG, they'll both go forever in either direction, but they're never going to meet, okay? Because AB is kind of a horizontal line in the back of that figure, and EG is a vertical line near the front of the figure. Okay, so they'll continue on forever, but they will never meet. So they are not coplanar. They will never meet. We call those skew lines. And then finally, parallel planes are planes that do not intersect. In this figure, plane ABE and plane CDG would be considered parallel. So in any three-dimensional figure, those faces that are opposite each other are parallel. Let's take a look at an example. This is like a house of cards here. Okay, and let's take a look first at the lines that we can conclude are parallel. You'll see we have a set of 4 parallel lines. They're kind of like the vertical edges of this house. NS, MR, LQ, and KP. Those are all parallel segments. Now note that even though KP and MR don't actually lie on the same plane, like they don't lie on the same card or anything, we can, if you can visualize kind of drawing a plane diagonal through this rectangular house, we could create a plane that both KP and MR are on. So it is okay that we're saying that those are parallel as well. Then we have another set of 4 segments that are also parallel. PS, QR, LM, and KN. And if we look at the perpendicular segments in the diagram, we can conclude based on the markings in the diagram that NS and SR are perpendicular, as well as MR and SR, and MR and RQ are also perpendicular. And finally, we have several sets of skew lines. Just one example is NS and LM. Those are skew. You can see that they will never intersect. They lie on different planes. They will never intersect. Another set of skew lines could be PQ and LM. Now on to angle pairs. Okay. The word transversal might be new to you. So by definition, a transversal is a line that intersects two coplanar lines at two different points. The transversal and the other two lines form 8 angles. So you'll see here in this diagram that transversal cuts through the other two lines, forming 8 angles. And we have special names for all of these types of angles. Corresponding angles lie on the same side of the transversal, on the same sides of the lines. Okay, so in this diagram, angles 1 and 5 are corresponding angles, but we also have 3 more pairs of corresponding angles, even though they're not listed here. 3 and 7 would be corresponding, 2 and 6 would be corresponding, and so would 4 and 8. The next set of angle pairs that are formed by a transversal are called alternate interior angles. Okay, and it actually says exactly what the terms say, alternate interior. So if we look on the interior, and they're on opposite sides of the transversal. So for example, 3 and 6 would be considered alternate interior angles, but so would 4 and 5. Alternate exterior angles lie on opposite sides of the transversal on the outsides of the lines. So 1 and 8 is one set of exterior, alternate and exterior angles, and 2 and 7 would be another set. And then finally, same side interior angles are angles that lie on the same side of the transversal between the lines. So 3 and 5 is an example of one of those pairs, but 4 and 6 are also same side interior angles. Let's look at an example. Okay, so here you can see the transversal cutting through the other two lines, forming our 8 angles. So if we wanted to look at the corresponding angles, 1 and 5 are corresponding angles in this diagram, as are 4 and 8, 2 and 6, and 3 and 7. So a transversal cutting through two lines forms 4 pairs of corresponding angles. The alternate interior angle pairs, there are 2 pairs of alternate interior angles. 4 and 6 would be one pair, 3 and 5 would be the other. There are 2 pairs of alternate exterior angles, 1 and 7, and 2 and 8. There are 2 pairs of same side interior angles, 4 and 5, and 3 and 6. And this wasn't in the last slide, but we also have something called same side exterior angles, which hopefully is self-explanatory. 1 and 8 are same side exterior, and 2 and 7 are also same side exterior angles. This example looks a little different, and depending on what angles we're looking at, any one of these lines could be considered a transversal, because if you notice, each one of these lines intersects the other two lines at 2 separate points. So let's just take, for example, if we look at line M as being the transversal, think for a minute, what type of angles are 3 and 5? Okay, so for transversal M, 3 and 5 would be considered same side interior angles. Now what about 3 and 6? So if we're looking at transversal M, what type of angles would 3 and 6 be? Well, they're on the same side of the transversal, and they're both below the other two lines. So 3 and 6 would be corresponding angles if we're looking at M as the transversal. Now let's switch gears and look at N as being our transversal. Hopefully you can tell that transversal N forms two sets of alternate interior angles, 1 and 5, and 2 and 6. Now let's see what you learned. If you click on the lesson quiz button, it'll take you to a Google Form lesson quiz that I'd like you to take before we head to class tomorrow.